All right, so here, first write down the characteristic equation. And then you have to, well, first try to factor this, and you'll find it's impossible because, see, 10 factors is 10 times 1 or 5 times 2. Neither one will pair up to add to 6, so it's impossible to factor. Okay, that means you're left with either applying the quadratic formula or use complete the square. And I guess complete the square is easier when this number here is even. If it's odd, then you don't have much choice. You'll have to go to that quadratic formula. Okay, if this is even, this is what you do. First, take the half of negative 6, which is
3.
Negative 3. Right? Half of negative 6 is negative 3. Be sure to include this sign. So put that there, and then you put squared. After all, the name of this technique is called completing the square. So you want to square it. And then you want to think about what number should be here in order for this squared plus that to equal to this number, 10. And you see, negative 3 squared is 9. 9 plus 1 gives you 10. So the number you should put in here is 1. Do you have a question?
What did you say before? You can't do what if it's odd?
Oh, if this number is odd, the number in front of r, if it's odd, then it's hard to do this technique because, I mean, it's not totally impossible, but if this was 5, for example, if you take the half of 5, you would be getting 2.5, right?
Yeah.
And it's quite hard to take the square of 2.5 and see what should be done here. So if it's an odd number, I guess you're better off using the quadratic formula. Okay? All right, now let's try to solve this. If you move the 1 to the other side, it's negative 1. You take the square root. And make sure whenever you take the square root, you have plus or minus. And we know that square root of negative 1 is I. And also, if I move the negative 3 to the other side, it's positive 3 plus minus I. Now, recall that in this case, you have your characteristic equation's solution in the form of A plus or minus BI. And in that case, we learned that the solution looks like C1 e to the AX cosine BX and plus C2 e to the AX sine BX. So that's basically the general solution. And in our case, what's the value of A?
3.
And value of B? 1. Therefore, your solution would be written as C1 e to the 3x cosine 1x plus C2 e to the 3x sine 1x. Okay, so this is the general solution, which will satisfy the original differential equation. But in order to satisfy these two initial conditions, you have to figure out what C1 and C2 should be. The initial conditions will determine these two free parameters, C1 and C2, because each initial condition will give you one equation, so that means you have two equations for the two unknowns. That means you can solve for C1 and C2, right? Okay, so let's do that. First, y of 0. What's that? Y of 0 is C1 times e to the 0 cosine 0 plus C2 times e to the 0 sine 0. Okay, what's cosine 0?
1.
1, and sine 0?
0.
Is 0. Okay. Always try to remember the sine and cosine graph. Sine is, you have just divided into 4 equal parts, and then sine is this. And cosine is divided into 4 equal parts. Cosine is this. Cosine, sine. And of course, you can figure out, if you know that this is 2 pi, half of 2 pi will be pi, half of pi will be pi over 2, and so on and so on. You can figure out that too. So just knowing this graph will tell you, oh, cosine of 0 is 1, and sine of 0 is 0. So that gives you just what?
C1.
C1 only, right? Because sine of 0 is 0, that's gone. E of 0 is 1, cosine 0 is 1, so C1 is the only survivor, and that should be equal to 3. Our condition was that y of 0 is 3, so C1 is equal to 3. We're using this one. C1 equals to 3. All right. Now we have to do y prime of 0 equals to -2. Let's see how that works. That means I have to calculate y prime. So y prime of 0 means I have to take that C1 e to the 3x cosine x plus C2 e to the 3x sine x. I have to differentiate this and then set x equal to 0. And that's supposed to be -2. That was our condition. So let's try to work on this. When you differentiate this and when you differentiate this, you need the product rule, right? And because you have two product rules, it's quite long when you compute it as it is. So a slightly better idea is to factor the e to the 3x out first and write it as C1 cosine x plus C2 sine x. That way, since it's a product of this function and that function, you only have to use the product rule once rather than twice. That saves you a little bit of time. So let's use the product rule. Leave the first, differentiate the second, and when you differentiate C1 cosine x, that's -C1 sine x. And then that's plus C2 cosine x. But that's only half of the product rule, right? What does the other product rule say? 3 times e to the 3x. So you differentiate the first, but leaving the second. C1 cosine x plus C2 sine x. So that's your derivative. And after this, you have to plug in x equal to 0. Again, let's remember that sine of 0 is
1. 0.
0. And cosine of 0 is 1. Okay. All right, and then you plug in 0 and you get plus C2 cosine 0, and then that's 3 times, this time only C1 is remaining, this goes away, so 3C1. So after all this calculation, at the end of the day, what you're getting is C2 plus 3 times C1. But we already know the value of C1. What is it? 3. So we have C2 plus 3 times 3, which gives you C2 plus 9. And that has to equal to what? That has to be same as -2. Therefore, C2 is? -11. Okay. So are we done? No, we're not done. We still have to go back and plug the C1 and C2 in. So C1 is 3 times and minus 11 e to the 3x sine. That is the final answer.